Hey, stat students, we're going to talk about probability distributions. Is it a legitimate probability distribution, and how do we find expected value? If we look at this first one here, we have a probability distribution. What is a probability distribution? A probability distribution is a list of the sample space, so all of the total outcomes that could happen in an event. And then under it is the corresponding probability with each individual event in that sample space, okay? Now, here's one where we have our sample space. We could, let's say we're rolling a die, or we're picking numbers out of a hat. Here's everything that could happen. We could get a 0, a 1, a 2, a 3, and a 4. And all that we have is the corresponding probability for getting a 1 or a 2. We want to be able to find the X value for that 3, 4, and 0. So step one, what we need to do is we need to set up an equation and set it equal to 1. What do I mean by that? What I mean by that is we know that this probability distribution has to equal 1. Okay, that probability distribution has to equal 1. So what am I going to do? I'm going to go back in time and I'm going to go to algebra. And I'm going to combine my like terms. So you can see that we have 3 x's there. So I'm going to go ahead and I'm going to combine those 3 x's. 1, 2, and 3. So that gives me 3x. Okay, and then I have my constants here, 0.3 and 0.1. I'm going to combine. And that gives us 0.4. All right, ladies and gentlemen, I have this whole distribution right here is equal to 3x plus 0.4, and I'm going to set that equal to 1. So anytime you have a problem that looks like this, and you know that you have to figure out an x value or a y value or whatever value they give or variable they give you, okay, we know that that probability distribution has to equal 1. We're going to combine our like terms, set it equal to 1, and then step 2 is we are going to solve for x. So let's go ahead and do that now. We need x by itself. On this side of the equal sign, I'm going to get rid of that 0.4 first, minus 0.4. That cancels. I have 3x is equal to 1 minus 0.4 gives us 0.6. All right, ladies and gentlemen, now I need to get x by itself, so I'm going to divide by 3. And divide by 3, and I get x is equal to 0.2. Okay, so what did we learn from this problem? We know that a probability distribution is a list of all of the events in a sample space, okay, or all of the outcomes, in a sample space. We know that each outcome will have a corresponding probability, and that these probabilities need to equal 1. So if we have to figure out a variable, we combine our like terms, set it equal to 1, and use algebra to solve for x. All right, let's look at this next probability distribution that we have. It says in 2010, there was 1,319 games played in the National Hockey League's regular season. Imagine selecting one of these games at random, and then randomly selecting one of the 2 teams that played in the game. So you can imagine, right, that we have all the games in a hat, we pull one name out. Then we know the Wild is playing the Sharks. So we put those names in a hat, pull out one of those teams, okay? Define the random variable x as the number of goals scored by a randomly selected team in a randomly selected game. The table below gives the probability distribution of x. So here are all the different outcomes for that sample space. And that's defined as your sample space. And then we have the corresponding probability with each outcome. Part A says show that the probability distribution is legitimate. So I talked about kind of what is a probability distribution up here. And one of the conditions of something being a legitimate probability distribution is the sum of each corresponding probability has to equal 1. So again, the legitimate probability distribution, the first thing you have to show is you have to show that the sum is equal to 1. And there's one other thing that you have to show. You have to say that each individual probability is between 0 and 1. And you literally need to just check that, okay? So what we could do right now is we could pause our video. We could add these up and make sure that they are equal to 1. Then what we do is we need to make sure that each individual's probability is between 0 and 1. And that is inclusive, meaning you could have a probability up here that's equal to 0. You could have a probability up here that's equal to 1. Okay, it just cannot be above 1 and it cannot be less than 0. Okay, can't be greater than 1, can't be less than 0. It can equal 0 or 1. And we're okay here on this one as well. Each individual probability that corresponds with the outcome is between 0 and 1. When I say show that the probability distribution is legitimate, you literally just have to tell me these two things right here. The sum of the probabilities are equal to 1, and each individual probability is between 0 and 1. Okay, let's move on. Make a histogram of the probability distribution and describe what you see. Anytime you describe a histogram, you want to use that acronym SOX, or if you had Mr. Jans, I think he uses SOX. We will review what that is. Now, if you look, I already have the histogram for you, and I'll just talk about how we got that, trying to save you some time on your videos. I will want you to pause the video right now, and I want you to draw the histogram. So we are on part B right now, the histogram. With the histogram, I want you to notice some things. Oops, that didn't work for me, did it? That's okay. What I want you to notice is on the y-axis, that's the vertical axis here, we have our probabilities. Make sure, like, how did I scale this? How did I know to start at 0.05 and go by fives all the way up to 0.25? How you know how to scale is you want to look at the maximum and the minimum probabilities. Okay, so if I look at my distribution here, if I look at my probabilities, my maximum looks like it is at 0.229. My minimum is at 0.001. And then it looks like, hey, I have a 15, I have a 0.09, I have a 0.06, a 15. So it makes sense to go by fives, okay? If you need help, right? If you need help how to scale this, just let me know and I'll help you. But again, I looked at my maximum and my minimum to scale the probabilities here on the y-axis.